Alright, welcome to 2-6. We're going to get radical here. I like the example that they've begun the section with. This is about the mathematics of tsunamis, and this was written long before that tragic tsunami hit in Indonesia. But you can see that the math of it has to do with square roots, and square roots are radicals, and that's what we're doing in this section. In this first sample problem, we've got the epicenter of an earthquake here near Japan, and we've got the markers showing the travel of the wave across the Pacific Ocean. And as you get to the problem, I suggest you read it carefully and look through and see what they're doing here using the equation that tells you the speed of a tsunami wave, that is, as a function of the depth of the ocean. And you can see that the speeds are quite extraordinary, 400 miles per hour on some of these waves. That's almost the speed of sound. Alright, so read through that carefully. Okay, we're going to look at just a few of the exercises in 2-6 to get right to the chase. You'll look at problems 1, 2, and 3, and they just want you to evaluate a function, for instance, when x equals 2. So if you pop 2 in there, you get 2 plus 4 is 6, and then you're taking the square root of 6 times negative 3. So it's just negative 3 radical 6 for problem 2. So you can try number 3 perhaps. And then in 5, they're saying just find s when t is equal to 5. So if we plug 5 in for t right there, we square both sides, and we get 25 then is equal to negative 5s plus 31. And you've got a simple algebraic problem, and you can continue that and solve that for s. Okay? But now down here at the bottom, I'm going to take some time to do this problem number 15 here. Z plus 2 minus 2 equals z. Alright? So take the book away and zoom out. Whoa, whose camera work is this? Alright. There I am. So to solve this, all we do is we isolate the radical, and to do that we add 2 to both sides. Plus 2 to both sides. So I get then z plus 2 equals, that's under the radical sign, equals z plus 2. Alright, so by isolating the radical, getting it by itself, we can then square both sides, and the radical will cancel when you square it, and you get z plus 2 equals z squared plus 4, right? I fooled you. It's actually got to be FOILed out. So if we write this 2 times z plus 2 and we FOIL it, yes, we get z squared, and 2 times 2 is 4, but with the rainbow check, this time upside down, it's 2z, and 2z is plus 4z. Alright, so now I've got this quadratic. Always with quadratics, you set them equal to 0, so I'm going to shove this stuff over to the other side. I do that by subtracting z from both sides. I subtract z, and I'm going to get 3z. Z squared isn't going to change because there's no z squared to get rid of, but when I subtract 2 from both sides, then I'm going to get plus 2, because I'll subtract 2 and subtract 2. Alright, so this is my quadratic. Well, you've got quad form on your calculator, so you can pop it in there, or you can see that it factors very easily to be z plus 2 and z plus 1. So my solutions then to be equal to 0 are when this is equal to 0 and when this is equal to 0, and that's going to happen when z is negative 2 and negative 1. So there are my solutions, but I want to pop them back in up here and see if in fact that works out. If I plug in negative 2 right here, negative 2 plus positive 2 is 0. The square root of 0 is 0. So is it true that negative 2 equals, and when I plug negative 2 in for z, negative 2 does equal negative 2. So that one's okay. When I plug in negative 1 plus 2 is a positive 1. I can take the square root of that, that's 1. 1 minus 2 is negative 1. I'm going quickly, but you can do this on your own. And that is indeed equal to negative 1. So both of these are okay. Alright? Okay, now we're going to jump to problem 31, where we're graphing a radical function, y equals radical 2x plus 2, and they also want us to state the domain and range. To graph these, I think that you can certainly plug them in on your calculator, but it doesn't hurt to have some concept of how to do it by hand. It's pretty simple. Your basic square root function, if you recall, is just going to go like this. It's a half a parabola that starts at the origin. We'll go out 4, for instance, and up 2. We'll go out 1 and up 1 because you're just taking the square root. Well, if we make a little chart for this thing, just off to the side here with x and y, when we plug in 0, for instance, we just get radical 2, which is about 1.414. If I plug in 2, though, that's going to give me 4, and 4 plus 2 is radical 6. Okay. If I try to find something a little simpler, I could plug in 1. 1 times 2 is 2. 2 plus 2 is 4. 4 square rooted then is 2. But I need to find out sort of some of its boundaries. For instance, x can be negative 1, and when I multiply that by negative 1, I get negative 2, and then that will add up to 0. So negative 1 is where I'm going to get my intercept of 0. So if I go to right here to negative 1, and then when I plug in 0, that's going to be 1.4. So there's 1 and 2. So it's going to be a little bit less than halfway. When I plug in 1, I go up to 2, so about up to there. When I plug in 2, I go up to radical 6, which is a little bit more than 2.5. And I go up like that. So it's going to be just half a parabola starting at negative 1. I should label these points. And there's 2, and there's 1, and there's 2. And that's a decent graph of this radical function. Okay, now the domain, that's my allowed x values. And you can see that if I put in negative 2, anything that's more negative, or a larger negative number, I should say, that's going to be, when you add it to 2, still a negative, and you cannot take the square root of a negative number. So I can't plug in negative 1.1. I can't plug in negative 2, because that would be negative 4, and when I add that to 2, it's still negative. So my domain then, I'll write my domain just shortcut like this. We can assume it's all real numbers, except that x must be greater than, or it can be equal to, negative 1. My range then are the numbers coming out, and you can see they're going to start here and then go up, whereas my x values start here and go over. So it's simply going to be all numbers y that will be greater than or equal to 0. So that's the domain and range for that problem. Alright, why don't you guys try problem 32, and that'll be a great start to this section.